The instructions are to solve the inequality. This is a linear inequality, and so what we'll do then is just get x by itself on the left. We'll add 2 to both sides, and we'll wind up with 3x greater than or equal to 1/5 plus 2. But we'll have to convert 2 to 10/5 in order to get ourselves a common denominator. So we'll have 1/5 plus 10/5, and then when we combine, we'll have 3x greater than or equal to 11/5. Now we want x by itself, so we'll multiply both sides by 1/3 in order to get x by itself on the left. And we'll wind up with x greater than or equal to 11/15. So here we have expressed the solution set for this inequality as an inequality. We could also graph it by locating 11/15 on the number line. And then we would put a filled in dot there because it says equals. It doesn't just say greater than, but it also says equals. And then we're supposed to shade to the right since it says that the solution set could be anything that is greater than or equal to 11/15. We could also express this in interval notation by first specifying the left endpoint for the solution set, which would be 11/15, and then a comma and the right endpoint, and since there is no right endpoint, we'll put infinity. Then we would open the interval with a bracket indicating that we do include this endpoint, and then close it with a parenthesis indicating we don't include this endpoint. We can't include infinity because we can't put a dot at infinity on the number line. Here again we have a linear inequality, and this one is a compound inequality because it's like having a sort of a three-sided inequality here. And the idea is going to be to get x by itself in the middle, and we have to remember that anything we do in the middle we have to do to all 3 places. So we might start by getting the 6 out of the middle by subtracting it from all 3 places here. So we'll have minus 11 less than or equal to minus x less than minus 1. Now, we don't want negative x in the middle, we want x by itself. So what we're going to have to do is multiply all 3 places by -1. And the thing that we have to remember when we work with inequalities is that when we multiply by a negative or divide by a negative, we have to turn the inequalities around. So these inequalities here have to change their direction. So what we'll have now is 11 greater than or equal to x greater than 1. And then the thing that kind of bothers us about this is that these values aren't written in order as they come from left to right. 1 is less than 11, so we probably want to write it with 1 on the left and 11 on the right. We just have to make sure that these inequalities are still appropriate. Here, the inequality between x and 1 points at the 1, so we have to make it point at the 1 again when we rewrite it in order. And then the same thing with the 11 and the x. It has to point at the x. So here we have this solution set expressed as an inequality. We could also graph it, and we would do that by locating 1 and 11 on the number line. We're going to put an open hole at 1 since it only says less than. It doesn't say equals. And then we would put a closed dot at 11 since it does say equals. And we would then shade that region in between. And again, we could express this in interval notation by first specifying the left endpoint, which is 1, and then the right endpoint, which is 11. We're going to use a parenthesis at 1 since we don't include 1, and a bracket at 11 since we do include 11. Here we have an inequality that involves some fractions, and we can easily take care of those by multiplying both sides by the lowest common denominator of all terms, which would be 6. So we'll multiply both sides by 6. And when we do that, we will distribute on the left. And so when we multiply 6 by 8/3, we're going to wind up with 16. 6 times minus a half is going to be minus 3x. Greater than or equal to, and then we'll distribute again, and we'll have 1 plus 6x. So now what we want to do is get all the x's on the left and everything else on the right, so we'll subtract 16 from both sides and subtract 6x from both sides. And so we'll wind up with minus 9x greater than or equal to minus 15. Now we're going to divide both sides by minus 9. And so we're going to have to remember to turn the inequality around when we do that. And we're going to wind up with x less than or equal to 5/3 when we simplify. Again, we could graph this solution set by finding 5/3. We have a closed dot at 5/3 because it says equals. And then we're going to shade to the left. And then put an arrowhead here indicating that it goes forever. Now, in interval notation, this time we would start at minus infinity and go to 5/3. Again, we'll have a parenthesis at infinity because we can't include it. And then we'll have a bracket at 5/3 since we have a closed dot here indicating inclusion of that endpoint, as we see here in the inequality form of the solution set.